right. Awesome. I think that's us. Can we maybe just close the door? Yeah, I think we're good to go. You can just close it. Okay, awesome. All right. So, hello everyone. Welcome to CS6 Practical System Skills. A new course developed just for you to teach you all about that there is art, like when it comes to terminal practical skills, so you know how to build stuff fast and beautiful. So maybe first some things about me. So I'm currently a third-year PhD student in the database management group. Previously, I was studying at TU Munich, Harvard, and also worked for BMW's self-driving car group. And currently, I'm working on like a new big data analytics framework. And so I was approached like half a year ago to kind of develop this new course together with like an awesome team of TAs, just to really teach you all kind of the insights when it comes to building systems, how to do things, and basically all the tiny bits and things. What currently is kind of expected that you know, but like it's pretty hard to learn on your own or take some time. So before we go into like the course itself, I want to introduce you to my awesome team of TAs. And yeah, Sam, why don't you start?
So my name's Sam. I'm the HTA. I'm from Ohio, and I'm a senior here at Brown.
My name's Hirsch. I'm also a senior. I'm from Atlanta, and I'm a UTA.
I'm Nina. I'm a UTA senior from San Jose.
I'm Raymond. I'm a UTA, a third-year concentrated in computer science, and I'm from the Columbus, Ohio area.
And we also have another couple TAs, which are not here right now, as you can see, James and Lena. And TA hours are currently not on the calendar. That's because we're going to go meet and figure those out right now. Also, if you have friends that have some level of coding experience and are interested in a course that's not a crazy heavy workload and like really like makes you comfortable with Git and the terminal and web development, all this stuff, like please tell them. We're a new course, so like PR is kind of hard, and like getting people to be like, oh yeah, come take this new thing that's never happened before. We really appreciate your help. So.
Okay, awesome. Yeah, thanks so much. So let's see, what do we have today? So the first question I kind of want to answer is like, who should take this course? So, well, the first one is like, you really want to learn like terminal skills, how to work comfortably like in a Linux environment. And we're going to do it like in kind of two steps. First, we're starting just like working locally. So that means on your own machine or on a department machine. And later we're going to take a spin on it and like do all the same things remotely and teach you how you can work on a cluster, how you kind of SSH into there, and just move your files, your workloads, and so on, and like all these kind of skills, what you usually see in the movies, what like some crazy hackers do or so. The other big part is like that when it comes to like building systems, a team is usually better than a single person, though there are like some awesome single person projects out there. And so we are also going to talk about like collaborative development. Specifically, we are going to use Git and teach like kind of the Git workflows and how to best work with the Git for your project and a team. And I think like what's also kind of cool about this course is that specifically the focus is going to be a lot on like what tools are out there to really help you build something fast and quickly, and what kind of considerations should you make that go a little like into like architecture or what to use, and kind of these things that really will speed up like kind of your system skills, hence like practical system skills. So prerequisites, what should you know? So this is not a course that's kind of an intro to programming, so we're not gonna talk about what's a variable, what's a if statement, what's like a for loop or while loop. However, we're really going to talk like from the ground up, like how this whole terminal business works, what commands are there, what kind of interesting things are to know about it. And so if you haven't taken any programming class, it's fine to still like go for CS6. However, you are strongly encouraged to take like one concurrently or like really bring your programming skills up to speed. Yes?
As far as classes that you would recommend to take concurrently with this one, do you have any?
I think like an intro class, like either like to objective programming or like general programming is a good idea for this class. You're welcome. All right, so today's lecture is split in like two parts. first, I'm just gonna give like a first lecture on like essentials of Unix. Then we're gonna have a small break of like 5 minutes or so, and then we're gonna just talk about like course logistics. And the good news is there's also homeworks in this class, and homework 0 is out today and should be also online on the website. So if you want to kind of check it out, you can always go to the website, and the link is just written on the whiteboard. And yeah, it's a very tiny homework that's mostly concerned about like setting things up and getting into the class. And it's due next Tuesday, 4 p.m. All right. Yes. Yes. But I will also talk more about homeworks in the logistics part. All right, so let's talk about Unix. So always interesting is kind of to see like how things actually started. The fun part about Unix is, at the beginning there was a game. It's called Space Travels or so, and we have a famous person, which is like Ken Thompson, and he was basically in his free time, work time at the Bell Labs creating a game, which kind of only survived as one single screenshot. And then there was an issue, well, it ran rather slow and it was not great, and so he did the obvious thing that you do in these cases, which is like developing a new operating system to make your game faster. So this is basically what started a project which is called Unix, in this weird spelling with like C and S. And well, it kind of got a little traction, so it was renamed after that just because Unix sounds a little cooler without like any meaning really. And it's like drew some inspiration from the Multics system, which was also concurrently developed at the lab. And then he met up like with one of his like co-working fellows, Dennis Ritchie, and they kind of continued development, rewrote most of the parts in C. And if these names sound familiar, that's actually not by chance, because they're basically also like the authors of like the C programming language. And in 1974, like, you know, after like 5 years, this whole thingy started surrounding this game. Finally, a copy of the software called Unix arrived at UC Berkeley, and they kind of tuned it, added stuff, and this is like the start of the so-called Berkeley software distribution. And well, in 1972, there was like kind of some presumption raised by both, and there was like, well, we think like, you know, the number of Unix installations is around 10 right now, so guess maybe some more people want to check out what we just written. Well, boy, they were right. So if we look at it, what happened after that, actually, it's not anymore one Unix, but rather it's a tree of like Unix systems. And so why is this relevant? Well, the interesting thing is that basically most of the systems surrounding us today are like based on Unix. And I just marked like kind of 4 important descendants or derivatives of the original Unix, which was like produced 50 years ago. And that's like, we have like Minix, which is like kind of an academic system, and like this is like usually taught in like any operating systems class. Then we have the Linux branch started by Linus Torvalds, and we have like 2 more other interesting branches, which is like the NextStep, OpenStep, macOS X branch, which is basically deployed in any Apple device right now. And we also have like kind of Google, which basically took the start the Linux kernel and made Android out of it. So as we see, basically Unix surrounds us everywhere. So when I say like Unix always, it's like kind of, well, do I really mean like the original Unix? Well, not really. It's rather like kind of a family of like systems, but like just short, we usually just say like, yeah, I'm working in a Unix-like environment or on like a Unix system and so on. And what's kind of also important is that there is like this big family of like Berkeley software distribution systems going down there. And why is this relevant is what we also will see over the course is when you kind of work with all these tools, they're like all partially coming still from there. And it's like not uncommon that you have like tools that are actually like 40 years old and just like really use them. So yeah, as I said, the conclusion, Unix is basically everywhere. So in this course, we're not going to deal with like smartphones and so on, but rather like basically devices that actually run like Linux kernel where we can do stuff, and they are not like kept by like some company in a sort of a closed source state. So when it comes to Linux, there's actually 2 persons that wrote a lot of software or inspired a lot of people to write a lot of software. So this is like Linus Torvalds, which started the Linux kernel, and Richard Stallman, who started the GNU project. And so what is actually GNU? Well, that's also like a funny story because GNU is basically one of these recursive acronyms that computer scientists love, and basically stands for like GNU is not Unix. And so you can kind of recurse that down, which is very funny considering that basically all the tools that are developed are what is known today, a Unix-like environment. But, well, I mean, sometimes there's like some fun in computer science too. So besides like kind of those general devices, there's a lot of interesting stuff that runs using Linux. We have like nuclear submarines, the New York Stock Exchange, high-speed trains, washing machines, smart fridges, self-driving cars. The Large Hadron Collider is running using Unix. We have SteamOS for like games, and also like pretty much every camera nowadays runs on like some Linux kernel also. And so the cool thing is, well, after you kind of learned how to deal with all these like terminal tools and so on, you can theoretically access all of them and work on every one of these devices because they all share the same architecture. So that brings us to a point, well, how shall we interact with a computer? Well, there's basically like two approaches, and I think like this comic kind of really illustrates the issue, like from the early days till today, which is like, well, I need a more user-friendly computer and I need a smarter human. And this is basically the divide of like, we have like a command line interface, which is great for a computer. It's just like the essential information that you need to run stuff fast. And you have a graphical user interface, which is way more human-friendly, but needs like additional resources and therefore is like way slower. And so in this course, we're gonna mainly focus on like the command line interface. And how does that like in general work? Well, there's basically a loop in like kind of the working approach with the command line, which is like first you enter a command, then the command is read by the computer, it's evaluated, the results are printed, and then you basically continue the whole thing. That's actually also like what you do on a terminal. You just type it, right? And then the computer does something, prints something, and then you can redo the whole thingy. So how can one learn how to work in a command line interface? Well, the issue is that it's actually quite complicated. So whereas like for graphical user interfaces, it's usually pretty easy. You should like have nice interfaces, intuitive where to click and what to track and so on in the best case. For a command line interface, it's difficult because it's more like learning a new language. That means like vocabulary and grammar really matters about that. So why is this fun? Well, I want to kind of show you like some example what this course will teach you over the next weeks. So let's say I'm going to look into homework 1. And in homework 1, there's basically written that I should read the syllabus, course missive, and collaboration policy. And so, well, the normal approach is like you go on there, you click, it takes a while to load. Okay, it seems rather long, so I want to download it somewhere. I have to select where to store it. I save it, then I go back. I do this again, and so on. And it will take a while, you know, it's like 3 files only, but it still takes me a while. However, I can also do kind of the same thing in the terminal. So just take like the address here, then I kind of just type it in. I get like some HTML code back. I see, okay, where's the syllabus and so on. Oh, it's like all PDF files. So I can basically just isolate them using like a regular expression. There's a typo. All right, there we go. So I just have now all these links, but I notice there's like kind of the first part of the URL missing, which is also not really a problem because what I can do is basically just take this part and then attach it. So now I have like all my URLs nicely listed. And now I just want to download them. So the only thing I have to do is basically run like some more commands. And already I have downloaded all the commands, and I can like also open up the whole thing here, and I just have them like already here. And that's kind of the useful skills this course is going to teach you. And like in 4 weeks, you will be pretty fluent doing all this stuff on your own. to the slides. So let's take a step back from like kind of a demo and really start first like what's going on in like a command line interface. For this, there's basically how you start is usually you start up a terminal window, you type your command, and you get like some output. Here it's like kind of an easy command, which is like the list command, which takes like some parameters and then prints out some results. So what's the general structure of a command? Well, first of all, you kind of have to specify what the command shall do, which is like kind of the name of the command you give. And then, because like the command can't know, or there has to be like some kind of input or like variation, so you can do different things, you want to pass it a bunch of parameters. And in general, we basically have the first argument, or the argument 0, which is like the command name. And then we have a bunch of arguments which specify different things. And there are like some conventions and naming conventions by them. And to like specify arguments, we basically separate them by white space. So what kind of arguments do we have? Well, in Unix, there's like kind of 2 possible arguments. One is like a so-called option, which can have like 2 flavors, either like comes in a short option flavor or a long option flavor. And this is always like kind of introduced by a leading dash. And the other one is like basically just parameters, which can either like be related to the options themselves or the command in general. And these basically then determine what behavior the command is going to have. So we have like here like an example. So for example, we have like here 2 short options, and we have the 2 parameters which specify basically 2 folders. So let's go into this a little more. So because it's like kind of cumbersome to type a lot of like options out, we can also like shorten them, and basically there's like the short options which have like just 1 letter, and we can just like concatenate them into 1 string. Like for example, if we have list minus L, minus A, minus G, we can shorten that to minus LAG. All right, you got a question?
Oh yeah, I was just gonna ask, like the double dash, is that
Yes.
mainly reserved for long options?
Yes, so basically the short option is just like a single character, and therefore you can basically concatenate multiple short options into like a combination of these short options, whereas the long options are like way more verbose, but you can't concatenate them. And so that's why they have like the double dash. Yeah, and also like when it comes to like long options, there's basically sort of 2 common syntaxes, and that's like either you have like kind of minus minus key equals value, or minus minus key white space value. And that's basically configure something like a key with a value. So the next kind of interesting question to ask is like, well, so now we know what like kind of parameters, arguments, and options are. How do we actually know how to use like some specific command? Luckily, Unix has therefore like another great command, which is the man command, short for like manual. And so what you basically can do is you basically just type man and then the command for which you want to bring up a manual page to know like how to use this command. So let's maybe just take an example. So let's say I want to learn more about the list command. So I just type man and then ls, and I get like here a manual page. And now we also know why like kind of the Berkeley software distribution matters, because list is actually a command that was written at Berkeley. That's what it always says like in the manual is BSD General Commands Manual. And then we have like kind of a lot of information what this command can do. As we see, it actually really is a lot of different things it can do. And we basically can control all this behavior by just adding options. The next question is kind of, well, we saw like the manual page, but like reading it all and understanding it is actually not that super easy. And that's often because there are like some conventions for reading man pages that are like expected from someone to know, but yeah, well, it's not obvious. So let's go a little through this, how to read actually a man page. So as we see here, we have like kind of the list command. We have brackets and a super long short option concatenated string. And then we have like another bracket, file, and then ... So let's dissect that a little. So first of all, if we have brackets, that means that the argument is optional. So you can either add it or leave it away. just dissecting that, we see like I could basically say, so all of this is optional, and this is also optional, so I can just run ls, and that's totally fine and valid syntax. Then there's another flavor, which is like kind of a vertical bar, which says that you can either write A or B, but not both at the same time. And then we have also like the ... which is like called the ellipsis operator in computer science. And that basically means you can repeat the previous one. So for example, in list, we can have multiple files repeated. And then of course we have like in the description section, a large description what each option basically does. So let's see that again in the terminal. So basically, we have like here first the synopsis, which kind of says how to use the parameters, what's optional, and so on. And then we can just like scroll down and see that, for example, -a says like include directory entries whose names begin with a dot. So this is like what this switch or option would do. Yes.
Is X A and B mean again? I don't know. When you said A or B,
Yes.
what is that?
Okay, let me give you an example for that. So, which is actually just on the next lecture slide. So, for example, here we have like copy, and we have here the vertical bar, right? So we have like -h or l. So that means you can basically use at this point h or l.
Or P or like
Exactly.
or P?
Yes. And so here it gets a little more complicated because it's basically gets nested.
I don't know. So when it says like or, it just goes to the first one that it sees?
No, you have to select it like when you write the program,
Okay.
right? But like basically, you cannot select like all things together. So for example, let's just take this example, right? So let's see what is like an invalid example. So here we have like copy -RHL. So why is this not legal? Well, first of all, we missed kind of here the two mandatory arguments, which is like source file and target directory. So this is why this not works. However, the first part is actually fine because we can like take either H or L and combine it with an R at this point. So this is like why this is okay. However, you can't basically write, you can basically not have sometimes at this nesting level like kind of a different syntax. Like you can't include at this nesting level, you can't say like -R -n, right? So you can't concatenate those together. Yes, exactly. So you have to kind of do that in multiple steps. So this is basically a nested syntax, and it's like a logical OR. And yeah, we also see like in the copy command kind of two versions, which are just like two alternative versions of the same command. So sometimes it's also like listed like 4 different versions of the same command or so. Yes?
Why are the valid ones using options that don't exist on this synopsis? Like A or lowercase b or
Okay, do you have like this one, for example? All right, let's look at this. So we have copy -a, right? So -a is actually here, and it's optional, so it's completely fine to use it. Yes.
So since it's like the APVX is concatenated, does that
Yes.
use 4 different options?
Exactly. So it's basically, you could basically add like the ORs in there too. So that's also what really makes sometimes reading manual pages so tricky, because there is kind of some notion of standard, but not everyone adheres to all these standards. Like, of course, it would be easier to kind of do that, but like also, like kind of when we have like, for example, the list command, you see like here, it's also like basically always an OR between like all of these options, and like each of these letters is actually one single option. Yes.
But it's also different from OR because you can use multiple of them together. It's not an exclusive
Exactly.
OR.
Yes. Exactly. All right. Yes. There's also another cool application of the manual command, and that's like you can actually learn what commands are available. So it's also like a search through all manual pages that are like on a computer. So I'm just going to show this here too quickly, which is like, so let's say we want to search for something related to a calendar. Then we see like there's actually a lot of things. something that's more like Apple specific and therefore looks weird with like the columns and so on. But then we also have like here 3 Unix commands, cal, ncal, and calendar. And so what I can do now is like basically just bring up the page of one of these commands by typing man cal. Then I see, all right, I have like a long synopsis. So here we have like an example where we have many different alternative versions of the command. And it basically tells me for what I can use it. And so I see, okay, I can basically use it without any parameters. So if I just type it, I basically get a small printed calendar in my terminal, which says that we have like today the 5th September. All right, this brings us to our next topic, which is like navigating the file system. So in Unix, there are like different type of files. And today we're mostly going to talk about like ordinary files and directories. And like next lecture, we're going to talk about symbolic links, and like 2 lectures about like device files and FIFO files. So what are files? Well, I guess like every one of you kind of worked already on a PC or so. And you have just like your typical directory structure, and you can rewrite it in a tree. So here I just have like kind of a music folder containing 2 subfolders with like 3 files in it, and they basically form a tree. And the first question is like kind of, how can I identify the position of a file within this file system? So the way it works is that each file has like a unique absolute file path, which identifies its location. And we call it an absolute file path for that reason. And the next question is like, so when we build our tree, we have to start somewhere, which is like the root. And so in Unix, the root of the file system is just like a slash. That means like if we assume that we kind of have the root and music folder is directly under the root, we can kind of create the absolute path to identify the don't stop me now file as like /music/queen/don't-stop-me-now.mp3. And so how to identify an absolute path is also quite straightforward. You basically just have to check its string representation, and if it starts with a slash, then it's an absolute file. So speaking of like absolute file paths raises another question, and that's like, it's rather inconvenient to kind of always just have like absolute file paths because they can get very long. And that is when you have like kind of a very nested or deep directory structure. So in order to kind of resolve that issue, there is the notion of like relative file paths. So considering you're currently like at, let's say, the CardB folder, which is like your current working directory, also often abbreviated as like CWD. The question is like, how can you refer to other files starting from this directory? And the way this works is like by introducing basically 3 special symbols, which is like the dot, the double dot, and the tilde. And these help you to basically form relatives starting from one current working directory. So let's see how this works. So here we have like a bunch of examples of like relative file paths. So we have just a dot, which is like the current directory. So that means if we're in CardB, dot is CardB again. Then we have like something like dot/queen, which basically means we go up one directory, we go to the parent directory, which is music, then we go down to like queen, and then we have like another slash, which is fine. And so we're basically then at like the queen directory. And that's like how it works like also for the other ones. And there's another special symbol, and that's like the tilde, and that refers to your home directory. Yes?
Is there a difference between having a slash at the end and no slash?
There is. So it's basically a convention thing. So identifying a file path, it doesn't matter. So if you just have like ..queen/, then this is totally fine, and it just refers to the queen directory, which would be the same without the slash. However, some commands interpret the end of the slash differently. That can be basically, if you just have ..queen, this means just the directory itself. But with a slash, you basically are considered to be further down there. So this is like kind of useful if you want to shift files down there or not, which we will basically talk about more in detail next lecture. So yeah, this is exactly the question you basically brought up. which is like kind of what the trailing slash means. And as I said, it's basically one way to identify that you have a directory and then refer that you're kind of in the middle between like your directory and the files or folders below. More on paths. Well, so if you type paths, there's like basically one issue in the terminal. That's like, let's say, let's say I'm like basically here. And that is like, if I want to type something like demo example, then this happens. However, I actually maybe wanted to check out if there's like a folder demo under demo whitespace example. So in order to solve that, what I can do is basically I have to escape this character because I know that there's a conflict since like arguments are separated by whitespace, and I can use that by introducing basically a backslash again. So what's kind of the tip or trick like for practical system skills at this point? Well, the idea is like, because escaping just needs like one more character when you type stuff in the terminal, you better shouldn't do it. Rather, it's like better to have like kind of Unix conform file names. And that is like you take like lowercase, uppercase ABC letters, dot, underscore, or dash. Like for example, like this is a good file name, whereas this one would be one where you have to escape like every single white space. And so the idea is like you should better not like use names including like special characters or like white spaces. Yes?
So use the backslash, like if you have two spaces, would be two backslashes, or just one?
Yes, so that would be kind of you escape one, and then you escape the second. All right. Another important thing when it comes to file paths is basically what the actual file name is. And so now this is like kind of a little complicated because what's the file name? Well, actually the whole thing is the file name, like the absolute path of it, because this is how we identify the file uniquely in the whole system. But when you talk kind of in real life about files or file names, you usually just refer to like the last part of it. And that's like what's shown like in your folder. Like for example, if you have the MP3, it's just like don'tstopmenow.mp3. And the way this is actually called is like the base name of the path. And how this works is basically you take the suffix after the last separator. So there's like here a bunch of examples. First of all, like when we just want to have the base name of the MP3 file like under home queen, this is like don't stop me now MP3. And then we have like the special cases, right? Because there's no trailing file separator before under, it's just like dot and so on. And we also have like here a couple more examples. And like here we just have like kind of a trailing slash. So that means like our base name is basically the empty string because we have no suffix in that case. So let's see how we can use that in the terminal. So for kind of navigating the file system, there's like three handy commands. And that's like print working directory, which shows you the current absolute path of the directory you are in. Then you have list, which lists the files in your directory. And you have change directory to change directories, which is pretty self-explanatory. So first, I want to talk a little more about like change directory. So we basically have like a couple options for that. First, we can just call it without any parameter, which will bring us back to our home directory. So what's our home directory? Well, the home directory is nothing else than the directory that you start in with your terminal, sort of, if you configure it like this. And you can basically think of that like if you just like operate a Mac or like any other system, it's when you open up a new Finder, this is where you're gonna end up. Then we have like kind of the tilde, which is just a special symbol for the home directory. And so basically the first two commands do the same. And then there's like kind of another twist on it, on like the tilde, and that is like we can go to the home directory of a specific Unix user in the system. And we do that by just like kind of taking the username and like prefixing it with a tilde. And so if you kind of visit websites around the web, you often see like something in the URL like /tilde user. And this is basically the website of the user. And the kind of syntax is just inferred by this command. Then we have like 2 more options. We can just like stay in the current directory, which makes not much sense, but is completely legal, which is like cd dot. We can go up 1 directory, which is like cd dot dot. And then we can also like switch to the previous directory. So for example, if we type like an absolute path, we can just go back to where we were before. And the last option, we can just type like some path, either absolute or relative, to kind of switch directories. So let's check out how this works. So basically what I can do is like first I list where I am. Then I can show that by like print work directory. So here I see I'm in /users/cline/lecture01. And so if I want to go up 1 directory, I just do like cd dot dot. Then I'm like now in my user directory, which is like identified by a tilde. I can also just go to that again by like going cd tilde. I can again list what's in there. I see I have like applications, documents, library, and so on, which is like basically the folder in the Finder. So I could go into like documents if I want to and see what's there. There's not more than like just resource.txt. I could also go like to an absolute path. So I could go to users, cline, and then let's say you want to go into music. So now I'm in the music folder. And let's say I want to go back to documents. So what I could type again is like change directory and then just a minus, and I will end up in documents. Yes?
What's the easiest way to go back to root without like cd dot dot?
CD.
How does cd goes back?
Yeah.
All the way to the root with just a slash?
So if you want to go to the root, you have to go to cd root, cd slash, right? But if you want to go to root in terms of like your home directory, then you just do cd. Yes. However, usually you don't have permissions to kind of either go to the root or like see what's there. Sometimes you do. So therefore, it kind of depends. But this is like all about like file permissions, which is like part of like the next lecture. All right. So I already used it a little, but let's talk a little more about the list command. So what can we do here? First of all, I want to introduce another kind of naming conventions for files. And that is like, sometimes you want some files to be not listed, which is, for example, if you have like configuration files, or you just want to hide like something like, here in this case, 2 files called hiding penguins and penguins. So Unix basically defines hidden files as all files whose base name starts with a dot. So, for example, here I have a basic directory structure visualized again as a tree. So I have like .hidden file, then I have a folder that's hidden. So again, it's the base name that kind of defines that. And I have hello and world. And so if I just like go into this directory, so if I list it, I just have kind of 2 files there, hello.txt and world.csv. However, if I want to see the complete structure of the directory, I can do this by using the option -a for like all, and then I see the complete directory structure. First of all, there's a dot just referring to the directory itself, dot for the directory above, like the parent directory, and then I have like hidden file and hidden folder. And so now if I want to list the contents of the hidden folder, I have again like these 2 files. Yes?
So like, is using the dot at the beginning something you can do when you're like creating files and folders? Like, or is that something? Is there another way to hide them?
So if it's just a single dot, this will refer to like the current directory.
Right.
But if you do like dot and like something, then you can basically create a hidden file by that. All right. Yeah. So and then we can also like have again the syntax with like the brackets and the ellipsis operator. So here we see basically list has an optional parameter, and it's actually an optional list of like parameters, which means we can list multiple directories. So for example, what I could do in the terminal is just again list without any parameters. Then I can do list -a. Then I can do list and then dot hidden folder, for example. which just gives me that. But I can also just give it another dot, which is just the current directory, and then I get like kind of both things listed at the same point, just like the current directory with like the 2 files and like the hidden folder within it. All right, so we already worked for like some of these examples. Just in case, I included more on the slides. And just to go a little more through them, we see like, so in this directory, we basically get like here just the 2 normal files. If we list everything, we get like all things, including the parent directory and the current directory, using like the dot syntax. Then if we go for the hidden folder, we get like the 2 files in there. If we want to list like something that basically doesn't exist, we get like some error message. And if we give like the 2 arguments, like just hidden folder and the current working directory, we get like kind of the syntax where it's like separated. The same works like kind of when we use multiple file paths. So if we use penguins.txt and hello.txt, then we see like, well, penguins is actually not contained in this directory at the current level, so there's an error for this. However, hello is there, so we get it listed. And if we just list a hidden file, we also get just the hidden file listed. And then there is that kind of the special case, and that's like if we have something like dot/dot. Remember, it's like a relative path at this point. So this is basically can be shortened to like dot because we go the current directory and then we go to the current directory. So we basically stay in the same directory. So this is the same as like just a single dot. So besides like all of these wonderful options that are in the manual page and that you can kind of explore on your own, there are like some options that I think are like particularly useful. And it's like first, you have the -G switch, which displays folders and files using colors. So you can basically differentiate what is a file or what's a directory just by color. Then you have -L, which is like for long mode or list mode, which kind of gives you a lot of information on your files in the directory. And another way to kind of distinguish whether something is like a directory or a file is by using the -F switch. And what this does is like it always appends a trailing slash to all folders and leaves file paths untouched. And we already saw before like the example that when I use like 2 arguments, like 2 file paths as arguments, I get like kind of this separate listing syntax. So each path gets like listed and then with like the columns and so separate. But sometimes I want to squash them together and just have like one gigantic list without this formatting. And for this, like the -D switch is kind of very useful. So let's try this out. So I'm again here, just by list. So let me clear it. We just have the 2 files. Now I want to have it in colors. Because it's 2 files, no color appears. However, I know that there's some stuff hidden in here. So if I use -A, I can activate that, and I see there's a hidden folder, which is now displayed blue. I can, of course, also concatenate those options together. So I have it here. I can basically do things like I can list the current directory and the hidden folder separately. So now I have kind of here the current directory. We see like current directory, parent directory, and the hidden folder are folders, so that's why they're blue. And we have the hidden folder separate again with like all the contents, yes.
Besides folders and files, are there any different colorings?
So I think for -G there isn't. However, there is the option always to configure the stuff to kind of give it different colors. And for example, for the other 3 special files, like links, FIFO files, and what was the other one? It's on the slide. You can define for each of those a different color, and that it will show them in like the command. Yes.
When you said that ls -G -A, the dot and the dot, it's just saying that we're in the current working directory and we're in it's also listing the parent directory.
Wait, so you mean this here?
Yeah. Whereas the ls -G -A.
Yes, like this one here, right?
Yeah, so, it's like so is that just listing there's 6 different things in there, or is it saying that dot is correlating to hidden file and hello text, and the double dot is relating to the hidden folder as well?
Okay, got it. All right, so first you basically combine the commands, right? So the -A lists all contents there. And like each directory, content is also including the current directory and the parent directory. That's why a dot and dot dot are there. Then we have also the hidden folder, we have the hidden file, hello, and world.
Oh, okay.
And then because like the current directory is a directory, we kind of have the color there. And we also have like dot dot as with a directory because it's also a directory. However, I think what you mean is also like, for example, if I just take like, let's say, hidden file, right? And I give it like a G, then it's just the file itself, but you don't see any more like the two dots. Yeah. As I said, so minus D is kind of convenient to squash it together. So if we see like, so if we have like kind of here the separate syntax with a colon, we can put this into one list again by just using D. And so because this squashes everything together, we get like this result. All right. So included in the slides some more examples, basically most of what I showed. We have also like here the F switch, which basically just does the same as the coloring, but like appends the slash. I mean, we can combine these two too, so we have like colors and slashes, like some people like that too. And the one that's missing is kind of what minus L does. So let's see what minus L does. So minus L basically gives you some more information. We are going to go over the details, what this information means next lecture. But basically, it gives you information when the file was last touched, who owns the file, and what permissions the file has. And also gives you some estimate how many bytes these files use on disk or in the system. So why is this like kind of interesting? Why do we need to know about all these options? Well, the truth is like there's usually not one approach to solve things in the terminal, but rather there are like multiple approaches. And the approach you pick really depends like on your personal taste and with what you feel most comfortable or like what options you do remember, which is also completely fair. So let's say I want to have a very simple task, which is like how to get an overview of the contents of a directory I'm currently in. Basically, already we have kind of three approaches. The first one is I can just use like the minus L command, which gives me a lot of information, and then I know that like there's like kind of some switch in it which says it's a directory or not, and I can kind of dissect it from that information. The other option is I just use like ls minus f and look if there's like a trailing slash or not. And the other option is like I can use minus g to see it like with a color. And so basically all these approaches work, but it really depends what your taste in it is. All right, so this means we kind of went through the first amount of slides, and at this point we're just going to do like a 5-minute break. So if you have questions, feel free to ask them, or if you need to use the bathroom or want some fresh air. And we're going to continue, let's say, what is it, 4 to 5, and then talk about logistics. Yes?
Wait, talking about like, I guess. Wait, how long is like the workload like every week? How long is it taking?
I mean, that's like all on the syllabus, but it's like, so for homeworks, it should not exceed like 5 hours. However, we kind of plan homeworks to not be like a super big burden, but more like kind of focus to really teach you the skills. So, I mean, of course, it always depends on you, like how much you actually need. I can't tell you like how long each homework is, but like the plan is 5 hours per homework. Yes?
This class, I mean, it's kind of related to logistics, but it doesn't cover like command prompt at all from Windows. It's only
No, it's only Unix, yes. Yes?
Will we be covering like the Git Linux or the Git terminal show?
Yes, so we will cover Git also later in the lecture, which is like in the logistics. So, I mean, if you want, we can also just continue the lecture, but I think it's kind of nice to have after like 40 minutes of like slides, a small break. Yeah.
We go for like sudo and stuff, like super user commands.
Yes, though of course, like I mean, super user is a kind of like if you administer a system well, you shouldn't be using much of super user commands.
Okay.
But I mean, of course, we will like cover what the role is and like how to use it properly. Yes.
I know we're going to cover some logistics, but
Yeah.
is our homeworks mainly like written or code based?
A mixture of both.
Will you be putting both this and the video on the page?
Yes. I mean, the slides should be already online. Sam, are the slides already online? Okay, so the slides should be already online.
Yeah, you go for the slides, you'll be clicking on the number. The number gives you the slides, and then for the lecture capture, you're going to be clicking on the actual name of the lecture.
Okay, maybe let's take a quick poll. Like, who wants to continue the lecture now? Okay, so I take it as a majority then. If you don't mind, we'll just continue. All right, let's talk about logistics. First, I want to just give you like a short overview what the course will cover. So the first month we're just like going to cover mostly terminal skills. So it means we just walk through like kind of the whole Unix stack, files, permission, streams, pipes, scripts, like how to write like terminal scripts specifically, how the whole thing works together, how to pass input, constructs like conditional statements, loops, and so on, arrays, dictionaries. We're going to talk about processes, specifically like foreground processes, background processes, how to start them, how to schedule them, and just how to work in general, like multiple processes. We are going to spend a week on text processing. So basically what I showed you in the demo before, how you can extract text, how you can manipulate them, and how you can basically make use out of that, all of course in the terminal. And part of that is also going to be how to effectively use regular expressions. Specifically, of course, since we're working in Unix, we're focusing on Unix regular expressions, which have like kind of their own syntax. After that, we are going to take like a small tour into websites and Git. And the main idea is there to basically introduce what workflows exist in Git, what commands exist, how you can effectively work together in Git, and also like how you can basically code up quickly a small website using HTML and start using CSS cascading style sheets. After this kind of first block, there's going to be a first midterm, and also this is going to coincide with the start of final projects. So after we kind of are done like with the basics, we're going to move on a little more to like kind of how to build a smarter website, which is not just like static and just like sitting there on some server. And from that, we're using Flask, which is like a Python framework to build a dynamic website. We're going to talk about how to persist state using a database, specifically using MongoDB and MySQL, which will also like take us around like 3 to 4 weeks. And as a next step, we're going a little into like data analytics. So we kind of did text processing before. Now we want to take it like the next level, how you can use like other frameworks, how you can work with data frames specifically, and how you can visualize your data. There's going to be a second midterm, and after there's going to be like kind of selected topics which depend a little like on what kind of final projects you want to do. And finally, the final project is due the 15th of September, and that's also the kind of the official end of the course. Yes?
For the data analytics, are we giving that in like a programming language, or would that be the terminal?
We're going to do it basically using like SQL statements and using like an underlying analytics framework, which can be like a database or a framework.
So with all this content, it's still going to be like average 5 hours a week?
Yes, that's the goal. Yeah.
Also, like, what's like the final project? Like, what is like the the idea of the final project?
Yeah, so the final project kind of depends a little on you, like what you want to do, but the scope of it should be like you kind of develop a website which does like something, and you basically report how to actually deploy it. So it has to be like a running website. It can't be just like some files on your computer. It has to be deployed somewhere in the internet and actually working, which is like kind of the scope of this class, to really give you some insight into like practical system skills from like A to Z. All right. With that, let's talk about homeworks. So we have weekly homeworks. Homework 0 is out today. I think it's also online already on the website. It's due next Tuesday at 4 p.m. There's no credit for it, however, you need it in order to register for the course. We don't have any late days, but you can submit like a homework up to 24 hours late, and if you do so, we will deduct 25% as a flat rate, which means basically if you submit your homework after Wednesday 4 p.m., it will get like a score of 0. Next up, let's talk about exams. So as I said, there are like 2 midterms. They are cumulative. They already have like scheduled dates, and because like kind of I don't expect you to remember all commands by heart, you're allowed 1 handwritten cheat sheet in every exam. And so what does it mean? I give an example on the next slide. However, the only thing is like you're only allowed the cheat sheet, so you can't bring like a loop or so to kind of have some micro text or so and like magnify it. So that's not going to work. So there's basically 2 approaches for cheat sheets. One is like kind of the optimistic approach, which like some students like to take just as a motivator, and the other option is like you kind of do it a little more defensively and just write out like whatever you want. So you're really free to take whatever notes and things on this cheat sheet, which you see fit, and can take this like into the midterm. Right, yeah, final projects are going to be done in like groups of 3 or 2, like depending how kind of the enrollment turns out. And as I said, the goal is like to build and deploy something, which is also really running. And each group has like a TA that will like advise the group, help out with problems, and like kind of guide them through like the time of the course. Right, grading. This course has no grade per se. It's a mandatory pass or fail class. So if you want to pass it, you need like roughly 70% or so. And breakdown is we have like homeworks 50%. We have the 2 midterms, which each count like 15%, and your final project, which is 20%. Okay, hours are all listed on the website. We have lecture always here, Tuesday, Thursday, 4 to 5:20. There are labs from 8 to 10 in CIT 201, which the first lab is starting next Tuesday, so when homework 1 is due. And yeah, my office hours are pretty much just like an hour before lecture, always in CIT 249. And yeah, best tip is to kind of just get the calendar if you're interested in enrolling in this course, because it has all of that online. And yeah, regarding TA hours, I think they will be updated shortly on the website. Right, resources. In this course, like most of the content is going to be on the slides. If there are like occasional additional readings, I will mail them and post them on Piazza. However, if you like books, there is like a list of optional textbooks which you may purchase. They all are kind of handy. So this is kind of the book for the first part of the lecture, which is called Linux for Beginners and Command Line Kung Fu. It's actually 2 books in one. And yeah, it's just like a kind of nice and handy guide for like commands, which we will cover in lecture. Yeah, the other kind of logistics are on the website. And yeah, I just want to talk briefly a little about like homework 0. So homework 0 is really not a big assignment. I think most of you will be done perhaps in like less than 30 minutes or so. So it's mostly just to get you into the course logistics, setting up things, and make you familiar with the course proceedings. As I said, it's due next Tuesday for that reason. And yeah, if you want to enroll in this course and pass it, you have to do it. It's available on the website. And yeah, please do. And if you have questions, reach out to the TAs or me. which leads us to the last point, which is if you have any questions. Do you have any questions? Yes.
What's like the difference between like Ubuntu and Linux? Or is it, what is Ubuntu?
Okay. Sure. So Linux itself just refers basically to the kernel. So and Ubuntu is a distribution. So besides the kernel, the operating system kind of has many more components, which is like something which is like the terminal, right? Like this has to be somehow done. That's not provided by the kernel per se. Then there is like I/O connectors for like hard disk, hard drives, and so there's drivers like for graphics cards. There are all the programs that you want to use. And so bundling everything together makes like a Linux distribution, and Ubuntu is just one of many different Linux distributions, which is a kind of a set of predefined programs that are bundled together. Yes?
Wait, are we gonna be like going over like Docker containers and all that stuff? Just like
Potentially for final projects. Okay, then maybe I have one more question. Can we maybe just take a quick poll, like which kind of class level everybody is? So who's a freshman? Okay, sophomores? Awesome, welcome. Sophomores, juniors, seniors, grad students? Okay, awesome, thanks.
Also, if you have, okay, so this is a new class. There are going to be things that go wrong. Probably will be my fault. If something isn't working or seems to not be working, it's probably because it's not, and you need to email me because I don't know that it's not working. If anything's not clear or not working or broken or something's missing from the website, please just email me. I'll be very responsive. Like my goal is to make this semester run as smoothly as possible from like a logistics point of view. Like permissions errors, for example. If you don't have access to something, it's probably because I forgot to change the permissions on it, and that's not great. So.
Okay, awesome, perfect. Good, I think then if there are no more questions, this is the end of the first lecture. Else, if you have any questions, feel free to always write me an email or just ask me directly.
And we have one more TA that